Hi, this is Synthchaser from synthchaser.com. Today we're going to be repairing this classic LinnDrum machine. It got exposed to some water, and you can see there's some damage here. Also, some of the buttons are missing. So let's fire it up and see what it does. So I turned it on, and right away I can hear some noise. It sounds like air escaping from a balloon. But let's test the voices. So we're going to test the drum voices first. Get a very faint hi-hat here. The slider is kind of cutting out. This hi-hat isn't working. Tambourine is intermittently working. Sorry, hi-hat is we're still on hi-hat. Toms aren't working. Ride isn't working. So some of the things are working, some of them aren't. Let's switch to percussion. Tambourine's not working. Let's see if I fiddle with the slider, if that brings it back. No. Conga. No. Cowbell. Yes. Claps. Yes. And then there's some random noise. That squealing sound again. Up here, none of these buttons seem to be working. So we're going to see if these are issues with the switches or the electronics. I'm guessing that that's a combination of both. For example, this button here does claps, but when I take it off percussion, it doesn't do the drum equivalent on the same button. So these switches, they're the same switches actually that are used in the Oberheim DMX drum machine. And they get dirty and the contact wires get bent. So some of them can be repaired. Obviously some of them are going to need to be replaced. But we're going to need to see how many switches are bad and need to be replaced, how many switches are working, and then resolve any electronics issues with ones where the switches are working but the function is not. So I'm going to open this up and we'll take a look at some of the switches. So right now we're looking at the back of the switchboard, and one of the buttons seemed to have no effect on either mode, and that was this top row second one in. I'm going to show you how you can test these switches to see if they're working correctly. So with a regular multimeter, go ahead and probe the two pins. These two solder pads are connected, so if there's a little hole, you can use that to stabilize the probes of your multimeter. Stick it in there, and with your multimeter set to ohms, at this point you should have no continuity, so 0L on the multimeter. Now when I push the button, let's see if I can put the multimeter somewhere where you can see it. So I'm going to push the button. So I got the probes in there. I push the button, and it goes to 0 ohms. When I let go, it goes back to 0L, no continuity. Now let's check the next one. And so that there's no continuity, I'm pushing the button, and there's still no continuity. So this switch is bad, and this first switch we tested is good. So let's move on to the next one. That's good. It looks though like it jumps around a bit. It could be a little dirty. Let's check the next one. That one is good. So what we're going to do is we're going to remove this board with the switches. We're going to open up the switches and we're going to clean them all. And then we're going to see where we stand in terms of which switches need to be replaced and which ones are working now. Before he contacted me about the drum machine, the customer replaced the power supply just to get the thing turning on and doing something. This power supply board he replaced with an aftermarket power supply board, and that's well and good, but the majority of the regulators and all the filter capacitors are actually on this board with all the ROMs, this lower board. And there's 6 large capacitors here, 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 ranging from 1,000 microfarads to 27,000 microfarads. And this is what you would typically replace in a power supply rebuild, these large filter capacitors. They're 30-something years old, and for sure they've dried up and they're not performing as well as they should. Plus, I mean, it looks like they're 85 degree capacitors, and ideally you'd want to use 105 degree capacitors, 105 degree Celsius capacitors for power supply applications. So we're going to replace these 6 capacitors when we clean those switches before we do any troubleshooting of the electronics. Additionally, since we know that some of the sliders are dirty, we're going to remove this board with the sliders, and we're going to desolder each of the sliders, disassemble them, clean them, lubricate them, reinstall them in the board. That way we can be sure if once we clean the sliders, once we clean the switches, that any electromechanical issues, dirt in sliders, corrosion on switches, is resolved. Any remaining issues would be electronics. I've removed the 3 boards I'm going to be working on. Here's the board with the switches. This is what it looks like from the top. This part was covered up by the panel, but the only thing on this side of the board are the LEDs and the switches. This is the board with the sliders and the potentiometers. So we're going to be desoldering each of these sliders and opening them up and cleaning them. And this is the board with the capacitors, the power supply capacitors that we're going to be replacing. And while we're not working on this board, we're going to want to wrap it up in something dark and put it away somewhere dark. These chips here are the EPROMs, which have the samples for the different drum sounds. And normally an EPROM, and I think I saw one on this board, normally an EPROM would have a sticker placed over this little window. That's because the way that you erase these is with UV light. So you expose this to UV light. The UV light shines through the window on the die of the chip and erases the memory. So these don't have stickers covering that up, so we're not going to want to leave it exposed to sunlight for very long. So when we're not working on this, we're going to put it away. So we're going to start with the switches. So I'll move these other boards out of the way, and I'll show you how to open up and clean the switches. So I'm going to show you how to open up these switches and clean them. So this is a switch that we knew was good, and this is a switch that we knew was bad from the test that we did just a moment ago. To open up one of these switches, you just need to remove the keycap, and with the board removed, it's pretty easy. Just kind of grab it and firmly but gently pull the keycap off. And that gives you access to the inside. And there's a wire that comes across a spring, and when it's compressed, it makes contact with another terminal here. So this is the point this is the switching mechanism here. And as you can see, there's some corrosion in there. And what we'll do is we'll blast it with a little bit of contact cleaner on the point where the two wires meet up. And then we'll work it, exercise it so anything loose comes off, and then we'll hit it again. And that should be sufficient to clean these switches. So then you just push the keycap back on, and it's reinstalled. So this is the one that wasn't working, so we're going to open it up. And I'm going to exercise the little lever, and I do see that it's making contact to the pin that it should. So this wire that comes across is connected to one of the 2 leads of the switches. So here's one that's off. So this is the wire that comes across here, and there's another little wire that gets pushed up against, and that's this lead right here. So I'm going to blast this with a little bit of contact cleaner and then exercise it. And then flush anything away, and then close it up. work them a little more. And I'm going to repeat this process on all the switches here. This one again, I can see, actually I can see some dirt on there. So we'll blast it with the contact cleaner. Exercise it. You can even stick the this fine little tool in there and kind of scrape anything away that's on the lead there. And I'll put the lid back on, the cap back on, and work it a little more. So I'm going to repeat this for all of the switches, and then we'll go through and test again to see which ones are bad. And if I notice any mechanical issues, so when I manually push the lever down, if it doesn't contact the bar, or if something's broken or bent inside, then I'll know about it by doing this visual inspection. Here's a close-up of what we're doing. So one of the terminals of the switches is wound into this springy coil and then comes across here. There's a spring in the bottom of the switch, and then the other terminal is bent and is a little bar there. So when you push on the cap, you're pushing this against that, and it's making contact right here. You can see that that contact is relatively shiny. That was one of the switches that was good. This is one of the switches that was bad, and you can see the point where it makes contact is all darkened there with corrosion or dirt. So that's what we're trying to clean up with opening up the switches. So you can see now that the formerly dirty contact is now clean and shiny. If contact cleaner isn't strong enough, you can use deoxit. You can also use a fine tool like a dental pick or tweezers to get in there and scrape free any of the corrosion that's on there. But you want everything to look nice and shiny when you're done, and you want to be careful that you don't bend or damage anything when you're working on it. So I've desoldered the base volume slider. There's four connectors, 4 pins, 1, 2, 3, 4. You desolder them from the bottom of the board, and then you can remove the slider. With the slider removed, you can fold back the 6 tabs that keep it closed up. I've folded this one back. You can use a small screwdriver and wedge it. It's going to be hard for me to do this where you can see. Wedge it in there and fold the tab down. So I'm going to do that to the remaining tabs on this, and then we'll open it up. So now the tabs are folded back, and I can open up the slider assembly, and I can take the shaft out of the housing. So here's the shaft, and then here's the conductive strip, and you can see it's totally filthy, and the resistive element is also filthy. I'm going to use some denatured alcohol to clean the gunk off of this. You can see it's just turning my my Q-tip black. On the carbon element, I'll be careful because I don't want to remove too much of the resistive element. But you'll see that the denatured alcohol isn't going to get this conductive track shiny. And for that, we're going to need to do something else. But first, I'm going to clean all the dirt out of there. I can see that it's gathered there at the edges, and that'll be what happens if you squirt contact cleaner into these. It won't really clean it, it'll just move the dirt around. So now for the conductive track, what we're going to do is we're going to use a Dremel with a wire brush attachment. For this, we're going to be really careful because we don't want to scratch the carbon track. We're going to take it on here and we're going to polish this up. You also don't want to hurt your finger, so do be careful. And you can see now the track there is nice and shiny, almost as if it were new. And there's one other thing that we're going to need to do while we're in here, and that's to clean up the wiper. You can see that there's junk there on the wiper. So first I'll rub it with some denatured alcohol to get the big chunks off, and then I'll take the wire brush and give it a polishing. Hold it the right way. There, the wiper is nice and shiny now, and it's ready to be reassembled. I'm also going to clean up this shaft since there's some junk on there. We don't want that just going right back in, so we'll clean that up as best as we can. I could use the Dremel on that, but this is going to be covered with a slider cap. And then the one more thing I'm going to do before I reassemble this, I'm going to get a little bit of this fader grease, and I'm going to apply it with a toothpick here on the top of the wiper shaft here. So it's not going to get anywhere where there's an electronic signal. It's just going to be on the part where the shaft rubs against the case. So now we're going to close this up, and it'll only go back together one way, and this is the way that it goes back together. So now with some needle nose pliers, I'm going to fold the tabs down that I bent back originally. It's hard for me to do this while maintaining this kind of angle for you to see with the camera. So then I'll do the other side, and you'll see that there's a nice smooth movement of the sliders, and they'll be ready to go back in the board. So then I'm going to repeat this with all of the sliders here on this board, get them nice and clean and smooth. So to show you that just spraying contact cleaner in these isn't going to get them as clean as disassembling and cleaning with the Dremel, I have another one here. This one wasn't the one that the customer was complaining about, so it's not as dirty to begin with. I can look in and I can see some stuff on the metal track. But let's spray some contact cleaner in there and exercise the shaft. This is how most people would do it. You know, they wouldn't need to take it out of the synthesizer or the machine. I do see some stuff came out the bottom. Let's open this up now and see how clean it really is. I folded the tabs back and let's open it up and take a look. And as you can see, it is still very dirty in there. This metal track that we polished up on the other one is all dirty, and there's a bunch of dirt here at the end of the track, and even still on the resistive element, the carbon track, I still see some dirt. So we're going to do this the right way, and we're going to desolder all of these sliders from the board. We're going to open them up, we're going to clean them, we're going to polish the track, we're going to lubricate them, and we're going to put them back together and solder them in. And this will be a more permanent fix than just spraying contact cleaner in. One more thing I should mention, use the helping hand to hold these. Don't try to hold them yourself like I did on the first slider. You're gonna get your finger, so be careful with that. We've cleaned the sliders and repaired and replaced all the bad switches, and we've recapped the power supply, and now we're confident that there's no electromechanical issues and that there's no power supply issues. And unfortunately, many of the problems that we're having still persist. Dead voices, extra noise. And what we're going to do is we're going to troubleshoot this with the oscilloscope. We're going to look into the electronics and find out what's what's at fault for these problems. So stay tuned for the next part of the video where we troubleshoot the electronics of the LinnDrum. This is Synthchaser. Thanks for watching.